Okay, we're going to go over number 1 and 2 on the exam 2 review. Number 1, we're asked to find the x and y intercepts and use them to graph each equation. So remember that the x-intercept tells us where the graph crosses the x-axis, and the x-intercept always occurs when y is 0. So I'm going to take my equation and I'm just going to put a 0 in place of y, and I get 2x equals 6. So if I solve that, I get x equals 3. Now remember, that is an ordered pair where the x is 3 and the y is 0. So that gives us our x-intercept. For the y-intercept, that's going to be where it crosses the y-axis, and this always occurs when x is 0. So I take my equation, and everywhere I have an x, I put a 0, and I get negative 3y equals 6. Divide both sides by negative 3, and I get y equals negative 2. Again, this should be an ordered pair. The x is 0, the y is negative 2. All right, so now I have my intercepts, so I can go ahead and plot those. So the x-intercept will be right here on the x-axis at 3. The y-intercept will be right here, and I'm going to try to see if I can get this to give me a straight line. Pretty close. All right, so you want to connect, and then remember the graph keeps going, so you do want to put arrows on the end. All right, let's try the same thing with B. I want to start with the x-intercept. So I know that occurs when y is 0. So I plug in a 0 for y, I get 4x equals negative 20. Divide both sides by 4, and I get x equals negative 5. So my x-intercept is going to be the point negative 5, 0. Now remember, for the y-intercept, that occurs when x is 0. Oops, I did that wrong. Try that again. That should be a 4 times 0 plus 5y equals negative 20. So I get 5y equals negative 20. Divide both sides by 5, and y comes out to be negative 4. So again, that's an ordered pair. The x was 0, the y is negative 4. So this will be my x-intercept up here and my y-intercept down here. All right, so my x-intercept is going to cross the x-axis at negative 5. I can put that point on there. The y crosses at negative 4. So now I'm going to try to draw the line that goes through those 2 points. All right, that looks pretty good. And then put my arrows on the end to indicate that it keeps going. All right, so for number 2, we're also asked to graph. Notice on A, I don't see any y's. So what I could do is I could solve it for x. I get 3x equals negative 6. If I divide both sides by 3, I get x equals negative 2. So remember, if you have a line where the y's drop out and you have only x's, that's going to be a vertical line. So find your x-axis, find where x is negative 2, and we know that we're going to be drawing the vertical line. That's decently close, I'll take it. All right, that goes through x equals negative 2. All right, so for B, on this one, I don't have an x, but I have a y. All right, so let's move the y's all to one side. I get 2y plus 6 equals 0. I get 2y equals negative 6, or y equals negative 3. So here's my simplified equation. If my x's drop out and I have only y's, that is going to be a horizontal line. All right, so I find the y-axis, I find where negative 3 is, and then I'm going to draw the horizontal line that goes through that point. All right, let's go ahead and finish out this page. Next we have distance. So our distance formula, I have to write really small here. It's a giant square root Underneath we have x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Right, I'm going to switch colors real quick. Remember, in an ordered pair, you always have an x and then a y. So an x and then a y. I'm going to call P my first point, so I'm going to put 1s for that, and for my second point, I'm going to put 2s. So I always recommend labeling that before you start plugging in. Alright, so if I start with my x's, x2 minus x1, that'll be negative 1 minus 4, and that will all get squared, plus 6 minus a negative 6, so you got to watch your negatives there, and that will get squared. So if I clean up my parentheses, I get negative 5 squared, and then 6 minus a negative 6, that's going to become a 6 plus 6, so that's going to give us 12, so that'll be 12 squared. So I get the square root of 25 plus 144. That comes out to be the square root of 169. Now this one comes out to be a perfect square. You can check it on your calculator if you don't know it, but it comes out to be exactly 13. All right, so in the next problem, we're going to look at one that doesn't come out as pretty. So remember, this is going to be x1, y1, x2, y2. All right, same formula. Always recommend writing the formula down first. So x2 minus x1 squared plus y2 minus y1 squared, and that's all under a big square root. All right, so for my x's, I'm going to go negative 5 minus 3, square that, and then 5 minus a negative 3 for my y's, and square that. So I end up with negative 8 squared plus, now remember this just becomes 5 plus 3, so I get positive 8 squared. So I end up with 64 plus 64, so I end up with the square root of 128. Now if we start breaking down 128, it's 2 times 64, which is 2 times 32. It ends up being a whole bunch of 2's. All right, so if I start looking for pairs to take out, there's a pair, there's a pair, there's a pair. So that's going to give me 2 times 2 times 2 on the outside and a leftover 2 on the inside. And that ends up being 8 square roots of 2. So I don't want a decimal approximation here. I do want a simplified radical.